Okay, for number 1, they want us to find the distance between the points -2, -3, and -2 and 4. So the distance formula is the square root of the difference of the x's, plus the difference of the y's squared. Okay, so this is going to be equal to the square root of x2 is -2 minus x1 is also -2 squared. And actually, when these are the same, when these are the same, the distance is really only the distance between those, which is going to be 4 minus a -3 or 7. But let's get to that in a minute. We have plus the difference of the y's is y2 is 4 minus a -3 squared. So this is going to be equal to 0 squared plus 4 minus 3 is 7 squared, which is the square root of 49, which is 7. And again, we really didn't need to do all this work here because the x values were the same. So I know it's just the distance between the y's. So one y minus the other y, and it's always a positive. Number 3 wants the distance between 3, -4, and -1, -4. So again, the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the square root. X2 is -1 minus x1, which is 3, squared. Y2 is -4 minus y1 is also a -4. Again, these are the same, so it's really just the distance between those. 3 minus -1 is 3 plus 1, which is 4. And if you notice that, you don't have to do all this stuff. This is -4 squared plus 0 squared, which is the square root of 16, which is 4. And again, you could have done that by noticing that the y values were the same there. Okay, number 5, you want the distance between -6, -2, and -7, -5. Okay, now nothing's the same here. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is going to be equal to the square root. X2 is -7 minus x1 is a -6. That's going to be a +6 squared plus y2 is -5 minus y1 is a -2 squared. This is a -7 plus 6. -7 plus 6 is -1, which is going to become a +1. And this is a -5 plus 2. -5 plus 2 is a -3. So this is going to be a +1 plus a +9. So this is the square root of 10. All right, number 7, they want the distance between -8 and 6, -8, 6, and 0, 0. Well, you can do the distance formula, but you'll see how easy it is when you have zeros here. We have the square root of x2 minus x1 squared plus y2 minus y1 squared. This is x2 is 0 minus -8 squared. That's going to be +8. And we have a 0 minus a 6 squared. Well, this is the square root of 0 plus 8 is 8 squared plus 6 squared. 8 squared is 64. 6 squared is 36. This is the square root of 100, which is 10. Now notice that because these are zeros, you didn't really need to build all this. It's just the square of this, the square root of the square of this plus the square of this. The square of this is 64. The square of this is 36, and then you could just go from there. Okay, number 9, they want the distance between 5, 4, and 1, negative 2. Now, because nothing matches here, we have to use the distance formula. I'm not going to write it down again. The distance is the square root of x2, which is 1, minus x1, which is 5, squared, plus the y2, which is negative 2, minus y1, which is 4, squared. This is the square root of negative 4 squared plus negative 6 squared. 4 squared is 16, 6 squared is 36. This is the square root of 52. Now 52 is not a perfect square, but it does have a perfect square factor, which is 4. So I'll break that down into 4 times 13. And we'll take the 4 out by square rooting it, and it becomes a 2 when we take it out. So we're left with 2 root 13. For number 11, they want the distance between negative 2, 3, and 3, negative 2. Again, nothing's the same. The x's are not the same, the y's are not the same, so we do have to use the distance formula. x2 is 3 minus x1, which is a negative 2. y2 is negative 2 minus y1, which is 3. This is a 3 plus a 2, which is a 5 squared. And this is 2 minus 3, which is a negative 5 squared. Both of those are 25. So you get the square root of 50. That's not a perfect square, but it does contain a perfect square factor. 25 is a perfect square factor, so I'll write it as 25 times 2. And then we can take out the 25 by square rooting it and get a 5. So our final answer is 5 root 2. Okay, on page 532, number 3, they want to know the slope between the points. This is number 3. They want to know the slope between 1, 2, and 3, 4. Well, the slope formula is the rise, which is the difference of the y's, over the run, which is the difference of the x's. So y2 is the y value of the second point minus y1, which is the y value of the first point. x2 is the x value of the second point over x1, which is the x value of the first point. So this slope is 1. For number 5, they want to know the slope between 1, 2, and negative 2, 5. So the slope is the difference of the y's, that's a 2, over the difference of the x's. y2 is the y value of the second point, that's y1. x2 is negative 2, x1 is 1. So this becomes 3 over negative 3, or negative 1. Number 7, they want to know the slope between 7, 2 and 2, 7. Well, the slope is y2, which is 7, minus y1, which is 2, x2, which is 2, minus x1, which is 7. This becomes 5 over negative 5, which is negative 1. And you could have seen that happening right from the beginning if you know what you're looking at. Okay, number 9, they want to know the slope between the points 6, negative 6, and negative 6, negative 6. Well, notice that the y values are the same, and the y values are on the top of the fraction. The difference between those is 0. So if a 0 is on the top of the fraction, I know the slope is going to be 0. Okay, but let's do it. Slope is the difference of the y's. y1 is negative 6 minus a negative 6 like that. And x1, or x2 is negative 6 minus x1, which is 6. So this becomes a negative 6 plus 6, which is 0, and this is negative 6 minus 6 is negative 12, and this is 0. But we could have circumvented all of that by noticing that the y values were identical, meaning we're going to have a 0 for the difference of the y's. When that's in the numerator, I know my answer is 0. So I didn't have to do any work there. Number 11, we have the slope between negative 4, negative 3, and negative 6, negative 6. So the slope is equal to y2, which is negative 6, minus y1, which is a negative 3. x2 is a negative 6, minus x1, which is a negative 4. This is a negative 6 plus 3. That's a negative 3. This is a negative 6 plus 4. That's a negative 2. So this reduces to 3 over 2. Okay, number 13. A is the point negative 3, negative 2. And B is the point 7, negative 6. And they want to know the slope and the length of AB. So let's find the slope first. The slope is the difference of the y's. So y2 is negative 6 minus y1 is negative 2 over the difference of the x's, 7 minus a negative 3, which is negative 6 plus 2, that's a negative 4, and 7 plus 3, that's a positive 10. So the slope here is negative 2 over 5. That's the slope. And now they want the distance. The distance is Pythagorean's theorem, which is x2 minus x1 squared plus y2 minus y1 squared. Okay. x2 is the x value of the second point, which is negative 3, or this, it's 7, minus the x value of the first point, which is negative 3. Notice that this stuff was that stuff over there, okay? And we're squaring this. And y2 is negative 6, and y1 is negative 2, like this. And notice that this stuff was that stuff there. So you kind of, if you did this already, you really didn't have to do all the work here. But this is going to turn into the square root of 7 plus 3 is 10. Negative 6 plus 2 is negative 4. This is the square root of 100 plus 16, which is the square root of 116. Now this is a little bit hard to break down, so off on the side you can go 116 is 2 times 58, this is 2 times 29. So in other words, this is equal to 2 squared times, that's a 29, times 29. And we can take out the 2 squared by square rooting, and it's just a 2. So our final answer is 2 root 29, and that's the distance between those 2 points. Finally, number 15. They want to know the slope and the distance between A, which is 0, negative 9, and B, which is 8, negative 3. Oops. Okay, so our slope is y2, which is negative 3, minus y1, which is negative 9, over x2, which is 8, minus x1, which is 0. This is negative 3 plus 9, that's a positive 6, over 8 minus 0 is 8, so the slope is 3/4. The distance is the square root of x2, which is the x value of the second point, minus x1, which is 0, squared, plus the difference of the y's. Y2 is negative 3 minus y1, which is negative 9 squared. This is 8 squared, which is 64. Well, let's just write it as 8 squared first. Plus, and this turns into negative 3 plus 9 is a positive 6 squared, which is the square root of, I don't know why I'm writing all these lines everywhere. Not sure what's happening there. But this is the square root of 64 plus 36, which is the square root of 100, which turns into 10.